When I mention quality professionals, what comes to mind? Go ahead, you can shout it out. What kind of person comes to mind when you're thinking about a quality professional?
Somebody with glasses.
Glasses.
Detail-oriented.
Checking the box on the check sheet. Yeah. I
Pocket
don't.
protector.
Yeah, pocket protector. I used to wear one. For real. Because it happened to me. I got the ink spot on my shirt, and I'm like, never again. But yeah, I think of those same kind of things too. I think of the person in the lab coat with the glasses and the check sheet and the conveyor belt of parts coming down the manufacturing line. They're like, pass, fail, pass, fail. Or if they're not in manufacturing, if they're working with development, they're seen as the people that have the big red stop button or the stop please. Stop, you're not following company policies and protocols. Stop, your T isn't crossed and your I isn't dotted. Well, I'm here to share a little story, an idea about how quality professionals are more than just manufacturing and that they have big impact on the concepts and the ideas for product design. At the point where an idea for a product is just a haze and a cloud above a team's heads. So, I am a quality professional, and really I started out as a mechanical engineer. That's what my degree is in. And then through work and career, I developed into quality engineering and reliability engineering. And quality professionals don't go to school to become a quality professional. You kind of fall into it. You're exposed to it at work, and you find a mentor that wants to mentor you and teach you the ropes. You take classes on your own and get certifications. You kind of have to self-make yourself into a quality person. Now, I normally say that I have 20 years of experience in engineering because that's my work and that's how long I've been getting paid to do engineering type of work. But I would really say that I've been an engineer since I was maybe 3. So this is my daughter. Now she's a little bit older now, but here she is 3, helping mom plumb the sink, carrying on the family traditions. Because my family was a bunch of engineers and do-it-yourselfers. My uncles and cousins were engineers. My dad was a tool and die journeyman maker and a plastic injection molder, and my mom ran the business side of things. They had their own business. And it was a mom and pop business. So it was a very family-oriented business, meaning they didn't take pictures of me at 3 working because they didn't want the evidence. But by the time I was in 6th grade, I was working the machines. I was making parts. So in the 90s, if you were ever pulled over for drunk driving and had to blow through a plastic tube for a breathalyzer test to see if you were under the limit, that might have been made by me on the machine. Now the thing about quality is that there's a habit of not including it enough in the upfront activities. We know intuitively that quality built into a product is a good thing. We look for quality products. But then what happens when we're designing and developing products? There's a general process for it. First we design it, then we make it, we sell it, we use it, and then eventually it gets disposed or trashed or recycled. And we're all consumers of products and things, so we're all constantly involved in buying, selling, using, and disposing of it. And manufacturing is fun. I worked in that space for a long time. But design is really where it all starts, and where it all starts to happen, and where design and quality designed into the product is where it happens. If you have a good quality product, you're going to be able to have a consumer base that thinks more highly of your product. So you'll be able to charge more for it, which means more money in your pocket, higher profitability. If your design is of a higher quality, you'll have a bigger market share for it. So you're going to be able to sell more, which means more money in the pocket. But there's also other benefits, and academics have studied it, and I've studied the academic papers and the books for you. You're welcome.
Thank you.
But they all showed an increasing trend with companies and in product development, that there's a direct correlation between the companies that do sharp, early, fact-based homework about the customers, the use environment, the risks, and the technology limitations. If they do that upfront homework in a team setting with a cross-functional team, they are at least 3 times more successful with their product designs than those that don't. And it's the same story with profitability and market shares. Now, the other statistic that I found is that only 20% of companies are doing this sharp, early, fact-based homework. They're not doing it well, but it seems so obvious. But why? When we talked in the beginning, we think of quality as a compliance activity. We're inspecting parts, we're auditing. We're checking at the end of everything that's already been done, was it done right? The other part of quality happens in design. The reason why companies have such a hard time with this early concept development is because maybe they don't know the tools or the methods or the ways to do it. Quality has these tools and methods and the ways to do it. Now, some of the parts of why it's so hard and why companies don't do it, well, is because it is hard. It's hard to talk to people with a different viewpoint and to get their advice and input on a concept. There's barriers between engineers who are making decisions daily about the form, fit, and function of a product, how it works, how the customer sees it. Daily they're making decisions and setting up requirements and specs, and there's a disconnect between them and the people that are the customers and the people on the team that work more closely with the customers. Marketing, sales, regulatory, and legal. There's a barrier there. And then another part of this barrier is, even if the marketing and customer people are available, what do you ask them? If you're not working with them, you don't know what to ask. You don't know what questions to even start with. So that's why quality can be a framework for design engineers to be able to get this early, fact-based concept development work done. Now, I mentioned that quality people are self-made, so not everybody is into quality. And that's okay, but it's a matter of recognizing when you might need help and what is capable when you do ask for help. This pruning, the framework for applying quality during a design development project when it's early in the concept, is sort of like taking your ideas and trimming them down, pruning them down to get rid of those development paths that you don't want to further develop, that aren't going to benefit into the best fruits of your team's labors. These tools help facilitate meetings and generate ideas between different groups of people with different backgrounds, and they're very graphical. They're people-focused, not just on the external customer and the user, but also all along the chain, all of the internal customers too. They use risk-based thinking. And when we're designing or working out a problem, we don't necessarily like to think of, what's the bad thing that could happen here? But it's worthwhile to do because then we can design out problems, prevent things from happening, and mistake-proof them. The other things that they can do is help uncover those ideas, because you're mapping out something that's graphical that everybody can get on the same page about. And this is without creating any type of prototype parts. Being able to prioritize ideas and give them a ranking when it's in a concept phase is a very powerful thing to be able to do. And when you do it before you have prototypes or any engineering drawings, you're not stifling or cutting off the ideas. You're able to more fully develop them. This is my work as a quality engineer. I have worked on the assembly line, and it's a very valuable position. But I think if design engineers who are responsible for all those decisions at the very front of the whole process learn some of the techniques or apply them with their quality and reliability engineering folks, then they'll be able to have increased profitability, increased design success, and increased market share. But more important than that, it'll be products that are safe, dependable, and easy to use, because it'll be designed with that purpose from the start. Thanks.